Let's now talk about kinetic and static friction. Well, let me demonstrate that again one more time. I'm going to show you how we can measure the coefficient of friction between the two surfaces, and then I will explain the difference between kinetic and static friction. Well, now you know that the force of limiting friction between two surfaces equal to mu times mg, where mu is the coefficient of friction between the two surfaces, m is the mass, and of course mg is the weight of this system. Now let's measure the force of limiting friction, and all I need to do is slowly, there you are. How many? Let's go. 0, 1, 2, 3, 4, 4.5. I needed 5 Newton to make the system move. So I got the force of limiting friction is 5 Newton. And what is the total mass? I measured the mass of this piece of wood, that is 230 grams, and this is a kilogram. That is 1,230 gram, 1.23 kilogram. And what is mg equal to? So I will be able to say mu equal to 5 Newton divided by mg is 1.23 multiplied by 9.8. Now, can you calculate that for me? Mu is 5 Newton divided by 1.23 times 9.8. That will be 5 divided by 1.23 times 9.8. I got this as 0.4. Now, tell me, what is the unit of this coefficient of friction? What is the unit for measuring the coefficient of friction? The force of limiting friction is measured in Newton. Weight of the block is measured in Newton. Therefore, coefficient of friction has no unit. Now tell me, if I now increase the weight, will the coefficient of friction change? I now need a greater force to move the system. Well, I now need 5, 6, 7 newtons. Well, because the force of static friction is directly proportional to the normal force, increasing the weight will not change the coefficient of friction. Because you increase the weight, the force of static friction also will increase. The coefficient of static friction is a constant for two given surfaces. Alright, now let's talk about the distinction between static friction and kinetic friction. Well, now watch this. When I want to move this, there is no relative motion between the block of wood and the table. Now, the force of friction, the maximum force of friction now is called static friction. But, now watch when I make it move. Now, how much force I need to apply to make it move? I need about 7 Newton. And watch now, to keep it moving, I need only 5 Newton. So, one more time. Watch that carefully. In order to set it in motion, in order to begin the motion, in order to break the force between the two surfaces, the maximum frictional force is 7 Newton. And you notice that the moment it begins to move, the scale shows a lower reading. Now, that's the maximum. The moment it moves, what's that? Alright, the moment it moves, you need only a less amount of force to keep it moving. What does that mean? It means the maximum frictional force between two surfaces that are at rest with respect to each other is greater than the force of friction when the two surfaces are in relative motion. But that can be understood, is that right? Because when they are in motion, the imperfections are sort of overcome. So you need only lesser amount of force to keep it moving. Now, the force of friction, the limiting friction between two surfaces that are at rest relative to each other, is called the force of static friction. We say the limiting friction is the force of static friction, and we will represent the force of static friction by F sub S. On the other hand, the frictional force between two surfaces when they are in relative motion is called the force of kinetic friction, and we will represent it by F sub K. So I hope this is now clear. In order to set an object in motion, you need to overcome the force of static friction that is much greater. Now this is now the force of static friction. The moment it moves, you can see the scale reads less amount. So the force of kinetic friction is less than the force of static friction. Now, if that is the case, you can see mu is force of limiting friction divided by the normal force. That means the force of static friction can now be written as that means this mu has different values for static and kinetic, depending on whether you use the static frictional force or kinetic frictional force. So I can say mu equal to, if I use Fs, I'm going to call that mu s. Mu s equal to Fs over mg. Similarly, mu k equal to Fk over mg. So we will be using two types of coefficients of friction. Mu s represents the coefficient of static friction, and that will be the force of limiting friction when it is static. The force of static limiting friction divided by mg, and mu k is the coefficient of kinetic friction, that is Fk over mg, where Fk is the force of limiting friction when the two surfaces are in relative motion. Well, now tell me, when you drive on the road, what is it that makes your car roll on the road? Well, the force that makes your car, the wheels of the car roll is the force of friction between the tires and the road. Now, that can be understood if you go to Buffalo now and try to drive on the roads there. They're all slippery and the friction is very, very small. That means if you try to put your foot down on the accelerator, the wheels will rotate, but the wheel will not roll. In order to make the wheel roll, you need friction between the tires and the road. All right. The question is the friction between the tires and the road, is it static friction or kinetic friction? What do you think? Well, I know most of you will be tempted to say It is kinetic friction. Is that kinetic friction? No. You see, when the wheel begins to rotate, a point on the wheel, at any instant, it is a point on the wheel that is in contact with the road. And the friction between the tire and the road at that time is the force of static friction. It is not the force of kinetic friction. Now, when does it become kinetic friction? When your wheels lock and the wheel begin to slip. That is when the force of kinetic friction sets in. And that is the reason why many cars these days come with anti-lock brakes. So when you brake, your brake should not lock. The moment the brake locks, your tires will cease to rotate. And from then on, your tires will slip. And the friction between the road and the tire at that time is the force of kinetic friction, which is less than the force of static friction. And that is the reason why when your car begins to slid, you lose control, because the force of friction is very small. So when you brake your car, you need to bring your car to a stop in a controlled manner. The wheel should continue to rotate so that the force of friction between the road and the tire is always the force of static friction. Alright? So I hope you understand the difference between the force of kinetic friction and the force of static friction. Alright. Now once you are able to overcome the friction between two surfaces, then one surface will begin to move over the other. If the applied force F is greater than the force of limiting friction, the box will move. Once the box is in motion, the two surfaces are no longer pressing together as tight as before, so the force of friction therefore decreases. When the box is in motion, the force of friction between the two surfaces is less than the force of limiting friction before they started moving. And therefore, the force of friction between two surfaces at rest relative to each other is called the force of static friction, and we will write it as F sub S. And the force of friction between two surfaces that are in relative motion is called the force of kinetic friction, and we will use F sub K to represent that. Well, you know that the force of kinetic friction is less than the force of static friction. And Fs can be written as mu s times Fn, is that right? Where mu s is called the coefficient of static friction. And what will be the equation then for Fk? Fk will be mu k Fn, where mu k is the coefficient of kinetic friction. Now, which of these is greater? Mu s is greater than mu k, or mu k is less than mu s. Mu k is less than mu s. Well, this is the case when the two surfaces are moving on a horizontal level. Now, what happens if you now place this box on an inclined plane? All right, let's look at that now.